Hello and welcome to GCSE Chemistry, topic C2, Bonding, Structure and Properties of Matter. This tutorial will cover part 4, Giant Covalent Molecules and Nanoscience. Starting off with, what are giant covalent compounds? Well, they involve strong covalent bonds repeated in large structures, for example silicon dioxide shown here. They have high melting and boiling points because of those strong bonds, and they don't conduct electricity. However, there is exceptions to this, which we'll look at later. They are hard and strong, and allotropes of carbon are all made of carbon. So here are some allotropes of carbon, which are giant covalent compounds. First of all, diamond. So the blue particles here represent carbon. In the structure of diamond, every carbon atom forms 4 covalent bonds. Diamond has a high melting point because of the strong bonds, and it's also very hard because of those bonds. There's no electrons that are free to move, and therefore it does not conduct electricity. Diamond is used in jewellery, but it's also used in machinery because it's so hard and can be used to cut diamonds. Graphite is also made of carbon, but this time the structure is different. This time, every carbon atom forms 3 covalent bonds. Also, it's arranged in layers with weak bonds holding the layers together. Because every carbon atom forms 3 covalent bonds, there is 1 free electron for every carbon atom. Those free electrons move through the structure and are called delocalized electrons. These delocalized electrons mean that graphite can conduct electricity because the electrons carry electricity through the structure. Graphite has a high melting and boiling point because it still does have strong covalent bonds. Because the layers can slide, it's used in lubricants, and it's also used in pencils. There's a myth that some people think there's lead in pencils. That used to be the case, but now there's graphite in pencils. Another allotrope of carbon is graphene. Graphene is a thin sheet of carbon, just 1 atom thick. It's really strong, light, and used in composites, so combined with other elements, and it does conduct electricity. Another allotrope of carbon is Buckminster Fullerene. Buckminster Fullerene, or C60, is arranged in hexagon arrangement as shown here, and is a molecule of carbon shaped like a ball or tube. Buckminster Fullerene can be used to cage other molecules, and it has a large surface area. Other fullerenes can form nanotubes and used in nanoscience. We'll be looking at nanoscience in a little bit. Polymers, these are also giant covalent compounds because they're made of non-metals, and they are long chains of repeating units, joined by covalent bonds. Rather than drawing out a polymer like this, you'd put a bracket around it and then put the letter N. So this could be the polymer polyethene. Polymers actually have low melting and boiling points, but they have stronger intermolecular forces, so they are mainly solids used in plastics. We'll be looking more at polymers in another topic. Going back to nanoscience. So nanoscience involves using nanoparticles. So nanoparticles are really small, so 1 nanometer to 100 nanometers wide. They've got a high surface area to volume ratio, and they can be used in smaller quantities but still as effective as using more. Nanotubes are tiny cylinders made of carbon. They can conduct electricity and heat. They have a high strength, they don't break when stretched, and they're really strong. They can be used as catalysts. They can be used to deliver drugs in the body. They can be used to conduct electricity in electronic circuit boards. They can be used in plasters and dressings to kill bacteria. And they can be used in cosmetics like sun cream. The issue with nanoscience is the long-term effects are not fully known, so some people are concerned with using technology of things that are so small. This means the testing and development of nanoscience has to be very rigorous and is still ongoing. If you pause the tutorial now and try this 6-mark question. Okay, so this is a common 6-mark question to compare diamond and graphite. First of all, you would say that they're both allotropes of carbon, so they're both giant covalent compounds made out of carbon. Starting with graphite, every carbon atom forms 3 covalent bonds. It's arranged in layers, and there's weak bonds holding the layers together. There are free electrons or delocalized electrons that move through the structure, which means that they can conduct electricity. They have high melting points and they can be used in things like lubricants. Diamond, on the other hand, is also made of carbon, but every carbon atom forms 4 covalent bonds. Diamond is a giant hard rigid structure. It has a high melting point and boiling point due to the bonds, and there's no free electrons this time, so it does not conduct electricity. In this tutorial we have covered giant covalent molecules and nanoscience.